Hello, my name is Jacob, and on behalf of encoord, welcome to the second video in the SAInt 101 video series. In this video, we will cover what SAInt networks are. If you have not watched video 1 in this series, please watch video 1, as this video will build upon the contents of that video. So before I get into what a SAInt network is, I want to talk a little bit about software mechanics versus software mindset. I'm in your shoes often. I actually recently joined a makerspace here in Denver, where I'm based, and I'm constantly learning new engineering software. And in learning so much engineering software, I often think about the software mechanics and the software mindset. When I say software mechanics, I'm talking about the looks and feel of a software. Sort of the questions about what buttons do I press to do which tasks, or how do I make a certain type of plot in this software. The software mindset, though, is the approach to doing an analysis in a software. So these types of questions are, how does a user of this software approach this type of problem? How do I combine the concepts in this software to do a process that I'm interested in? And so you'll hear throughout this video series, I'll refer to software mechanics and software mindset. What is a SAInt network? Well, SAInt networks have objects. The three basic types of objects are nodes, branches, and externals. In SAInt, a node represents a physical or virtual location within a model where energy can be injected into or extracted from a network. Branches are a directed connection between a pair of nodes, and externals are an object directly connected to a node, extracting or injecting energy at that node. There are some other objects, so let's look at the documentation. In the reference section, I can find an objects subsection with an electric objects page. I can scroll down to this helpful diagram that shows all the electric object types. We see the ones we've talked about: electric nodes, electric branches, and externals, but we can see that there are a variety of other objects. And we'll talk more about these other objects in future videos. Now let's look at how these objects are represented in the SAInt graphical user interface. First, let's open the eNet39 network we just downloaded. I'm going to go up to the Network tab, Open Electric Network, and click on the eNet39 that I just downloaded. Once it's finished loading, I'll click OK. First, we can see objects are visualized on SAInt's map. We can see our nodes, branches, and externals. You can change specifically what's visualized in the map display settings. For example, maybe I want to show the base voltages of the nodes instead of the nameplate capacity. I can also hide these windows by using the auto hide icons. Objects can also be visualized in the Model Explorer. As we just talked about, we can see our nodes, branches, and externals. This model has 39 nodes, 46 branches, of which 34 are lines and 12 are transformers, and 40 externals, where we can see a breakdown of the objects types and their counts on the left here in the Model Explorer. In SAInt, objects have properties. So networks have objects, objects have properties. Common ways of viewing and editing properties are the property editor or object tables. To use the property editor, let me click on an object in my Model Explorer. Let me click on this first line, and I can make my property editor a little larger. Here I can start to see some of the properties of this line object in SAInt. Another way of viewing the properties of many objects at once is using the table. I can open a table of all the lines by right-clicking on the lines and saying Open Electric Line Table. Here I can see a table of all the electric lines and their properties. I can also open tables by using the Table tab in the ribbon up here and selecting from different pre-configured tables from this menu at the top. Now in this video series, we're going to talk about many types of properties. The first types of properties we're going to learn about are network input properties, and those can be divided into read-only network input properties and editable network input properties. These are going to be properties that are defined for objects on the network level. When building your own dataset, you would specify these properties manually, or if you're using a translation tool, these properties would be specified during the translation process. To clarify the distinction between network input and read-only properties, let's look at the property L and LGO of a line. Coming back to my graphical user interface, let me find the length of this line. I will scroll down and find the L property. This line has a length of 95.44 kilometers. Its geographic length is also 95.44 kilometers. However, the geographic length is defined based on the Euclidean distance between the to and from node of this line, and therefore I cannot edit this value directly. I would have to change the locations of the nodes. But what if in reality this was not a straight line, and in fact it curved around a mountain or something? In that case, the geographic length of the line may differ from the length that I want to use for mathematical calculations. So I could change the line length used for mathematical calculations to be something different than the geographic length. So in this case, line length is an editable input property, whereas geographic length is considered a read-only input property. Let's do our second exercise. So given your coworker sends you a network, the ENet39 for example, the ask is, what fuel does the Siemens generator consume? Please pause this video to complete this exercise. Let's work through this exercise using SAInt's GUI. So if I were completing this, I would first open up my network. In this case, the problem said we were using the ENet39. We've already opened the ENet39 and have been using it to do some demonstrations. So we've done that step already. The question asks about the fuel that the Siemens generator is consuming. I know that fuel is a property, so now I need to find the Siemens generator object. There are a few ways that I could do that. We could use the Model Explorer, and I could find in the externals, there is a fuel generator called Siemens. If there were many generators, or perhaps I didn't know if Siemens was a generator, I could use this search bar up here and type in SIMONDS, the name of the generator, and I see that this generator comes up as a fuel generator. I can click on that generator and look at the properties of the Siemens fuel generator in the property editor. Looking at the property editor, I can clearly see that Siemens is a natural gas generator. Thank you for watching the second video in the SAInt 101 video series. In the next video, we are going to cover SAInt scenarios.